Okay, so where were we? Chapter 21. Yeah, so I gave you the acids and base question, so I'm going to give you the solutions to these. It was an exam paper question, so I'm going to give you the solutions, the answers to each of these. And if there's any issues, you can let me know. Hopefully there isn't. So I'm going to give you the answers, and there's kind of a few variations of answers, so you might not have got the same answer as the person sitting beside you, but that still might be a correct answer. Okay, so I'll give you those solutions and let me know how they go. We're then going to move on to chapter 30. So chapter 30 is in the physical world. So we're back doing physics. Yay. So current electricity is essentially what this is about. So they have the learning intentions for this chapter. So correctly use the terms current, potential difference, and resistance when talking about electricity. So today we're going to concentrate on current and potential difference and the terms. We're also going to talk about how we measure current and potential difference, and we will move on to resistance then. The relationship between current and potential difference is something you're going to figure out. Recognize the symbols used for various objects that are commonly used in the study of electricity. So, for example, the battery has a symbol. When you draw a circuit diagram, there are universally accepted symbols. So you don't draw a picture of a battery, you draw the battery symbol. You don't draw a picture of an voltmeter, you draw the voltmeter symbol. Okay, so there's universally accepted symbols that we're going to use both for components in a circuit and also for like units. We've done a bit of this before, but for units and things like that, and do simple calculations involving current, potential difference, and resistance. So yeah, we won't be doing that today. So we'll be doing bits of the first 4 today, bits of them, and then we'll go back and fill in the gaps. Okay. All right. So what is electric current? So we discussed. I can't remember if it was the end of last year or the start of this year. I think it was the end of last year. Anyway, we discussed electrons. We did. It was last year. Remember we talked about you had your atom, and in here you had a certain amount of protons and a certain amount of neutrons. And do you remember you had your orbits? And out here on your orbits you had your electrons. Remember this? Okay. So electrons are negatively charged particles. Okay. And if you have a object, a wire, something like that, which is a conductor. Okay, so I'll show you a conductor now in a minute, but a conductor allows current to flow. So if you have an object that is a conductor, the reason it's a conductor is because it has a load of free electrons. Okay, so here is like a blown up version of a wire. Okay, so let's say this wire is like copper or something that's really conducting, okay, something that's good at letting electricity pass through it. It would have a load of electrons, and they're called free electrons because they're not in bonds, they're just kind of floating around in the wire. Okay, now if you hook them up to a battery, okay, so this here is your battery. So we said electrons were negatively charged. So a battery has 2 terminals. It has a negative terminal and a positive terminal. You should have noticed that from, just your regular little, the little cylindrical batteries. And one end always has a plus on it and one end always has a minus on it. So every battery has a positive terminal and a negative terminal. Okay, so if you attach up your wire to your battery, what happens is the electrons, which are negatively charged, they're repelled, because remember, like charges repel. Okay, we talked about that when we were talking about forces. So like charges repel, which means because these electrons are negative and this is the negative terminal, they want to get away from the negative terminal. So they move in this direction towards the positive terminal, which they're attracted to. Okay, so what you have is the free electrons that are in the conductor. Once they're attached to a battery, the force that the battery is applying on them causes the electrons to move. And once you have moving electrons, you have current. Does it say that there? Yep. The movement of electrons is called current. Okay, so the wire alone has the electrons sitting in it. So here's your wire, and here's your free electrons sitting in the wire. Okay, that's grand, that's great. They're not going to do a whole lot. Okay, but if you take a battery, here's the positive terminal and here's the negative terminal, and you connect that battery here and here, all of a sudden those electrons are being pushed by the battery, and this is the negative side, so they're going to move in this direction. Okay, once you've got that movement, you've got current. Okay, so the movement of electrons is called current. Now, this next thing is really annoying, and I can't believe scientists the world over have allowed this to happen. But essentially, you can see it here. Electricity was discovered before the electron was discovered. So you had a load of scientists who, it was actually Benjamin Franklin's fault, if we're going to blame someone. Okay, so you have your battery here, which is positive and negative, and then these scientists put a wire, right, like this, and they put in, let's say, a bulb. Yeah. And then in here, they put in, like, I don't know, a little piece of metal. Okay, something like that. Okay, the metal conducts. So they didn't know what was in the wires. They didn't know about electrons. They didn't know about free electrons. So they had no idea. All they knew is that when they connected up this circuit, the light bulb came on. Okay, and if they took this metal piece out and left a gap in the circuit, so if they, put that back in, sorry, they left a gap in the circuit like this, then the bulb went out. Okay, so they knew that something was going around this circuit. Okay, it was like flowing in the circuit. They knew something was flowing, and that was causing the light bulb to light up. But they had no idea what was flowing. They had no understanding of electrons or anything like that. So they didn't know if it was going from positive to negative, like I've drawn there, or if it was going from negative to positive, as in the opposite direction. So essentially what they did was they guessed. Okay, and unfortunately it was a 50-50 shot, but they guessed wrong. Okay, and again, this, for some reason I can't understand. We still talk about the incorrect guess. Okay, so if you read this bit here, electricity was discovered before the electron was discovered. In the early days, when scientists first studied electricity, they agreed that current was the flow of positive charge from positive terminal of the battery to the negative terminal of the battery. So they said it was flowing in the yellow direction. Okay, it wasn't, because we know that it's the electrons that are flowing, and electrons are negative, so they would follow the pink arrows. Okay, but like I said, they didn't know that, so they guessed. So they went with the yellow arrows, and we still talk about conventional current. Okay, so conventional current is the direction a positive charge would move in a circuit. All right, so again, it wasn't the positive charge that was moving, but they didn't know that. Sorry, I'm just going to get rid of this. Yeah. So it wasn't the positive charge that was moving, it was a negative charge that was moving, but at the time they didn't know that, so they just guessed and they went with a positive charge, and they ended up being wrong. But we do still talk about conventional current, and a lot of definitions and a lot of calculations you do at Leaving Cert Physics would all be based around conventional current, which is the opposite of actual current. So actual current, which is up here, is the movement of electrons. So that goes from minus to plus. Conventional current is the movement of positive charge, which goes from plus to minus. Okay? Right, how do you measure current? You measure current, okay, so current, the unit for current is the ampere. We tend to just say amps. So I know most of you we don't really have fuses anymore, but I know when I was a kid, if a fuse went in your fuse box, your fuse box, it's normally in your hall, and we now have like trip switches. So we have, they're called circuit breakers. So if, I don't know, you plug too much in, the switch trips, and you just go down to the hall and push it back up again, and everything works. It wasn't like that when I was younger. It used to be a little fuse, and the fuse would blow. So you'd have to go to the shop and get a new fuse to get everything working again. And the fuses were different. You can get a 13 amp fuse, or a 7 amp fuse, or a 3 amp fuse. So yeah, I don't know if you've heard of amps before, but it's short for amperes, and the symbol is A. Okay, so when we're talking about current, we would say a 13 amp, whatever, current. Okay, and current is measured with the instrument used to measure current is called an ammeter. Okay, I always think of an ammeter like, I don't know, like a little person in a toll booth counting, right? So here's your wire, and here's your wire at the far end, and you've got like your electrons coming through, and every time an electron passes this person here, they count. So they go, right, that's 1 gone, 2 gone, 3 gone, 4 gone, and that's essentially what current is. It's the electrons flowing in the circuit. So when you want to measure current, you take your ammeter and you put it into the circuit, because you want the electrons to flow past the county person. Okay, so they flow right through the county person, and this person will count how many electrons, and that will give you the number of amps flowing. Okay, so I'm just going to show you this. I'm going to get you to do this yourselves. Okay, so there's my battery, and I'll put in a wire, another wire. I'll throw in a switch for safety, because it's always good to be safe. Another bit there. I'll put in a bulb, another wire. Okay, so you can see here, see all these little minuses? They're my electrons. Okay, and when I close this, now, yeah, so when I close that, the electrons are moving. You can see them moving to the circuit, which means, what do I have? I have current. And the current, you can see it passing through the bulb, and that's causing the bulb to light. Okay, so like I was saying about Benjamin Franklin and his friends, if I break that circuit, no more current flows. You need, now how do I put this back together? There you go. Oh, I took the switch out altogether. Oh well. Right, so you need the circuit to be complete, so that the battery is exerting a force on the electrons and pushing the electrons from the negative terminal around to the positive terminal, and that's causing the bulb to light. Yeah? So if I want to measure the current, so if I want to get a reading for what size current is flowing here, I need to use an ammeter. Okay, see this over here? Okay, and remember, you think about this like a little person who wants to count all these electrons passing through. So you need to put it into the circuit. Okay, so I broke the circuit, and I'm going to put my ammeter into the circuit. Okay, so you can see it starts, I can't straighten that out. Anyway, you can see it starts moving again, and now we're counting the current. Okay, so the current here is 0.9, and there's your A for amps. And if I click on this, I can bring this up. And you can see when I did that, I made the battery way stronger. So it's exerting a much bigger force on the electrons. So the electrons are going much faster. The bulb got much brighter, and you can see that our reading went up a huge amount, okay? Because the person in there now is like 1, 2, 3, 4, 5, 6, that has to count really, really quickly because that's how quickly the electrons are passing. Okay? So that is current, okay? So what is current? It's the movement of electrons. The unit for current is the amp. And the device used to measure current is an ammeter, and that ammeter needs to get put into the path of the circuit. It's quite important that it's done that way. Okay, so now we're going to talk about voltage. Okay, now I already messed with the voltage in that simulation there. The voltage is the driving force. Okay, so in that kind of second go around there, I pushed the voltage up. I made the battery stronger. I gave it a bigger driving force. Okay, so essentially what happens inside the battery is that there's a chemical reaction. Okay, so a chemical reaction occurs inside the battery. The battery is filled with chemicals. Chemical reaction happens, and it gives you an excess of electrons on one terminal and lack of electrons on the other terminal. And a lack of electrons means it's positively charged. Okay, so if you've got extra electrons, that means you've extra negative charge. So this terminal becomes negative. And in this case, if you've got a lack or a loss of electrons or negative charge, that means overall this terminal will be positive. Okay, so you have a difference between these two. Okay, that's where this comes from, a potential difference. So there's a difference between these two. If you then attach these up to a wire, any electrons in the wire are going to be repelled from that, and they're going to move themselves around and be attracted by the positive terminal. Okay, and depending on how big the difference is between these two, okay, how big the potential difference is, these electrons will either move nice and under control and slowly, or they'll fly around like what I did with the simulation. Okay, so the difference between these two, the potential difference between these two, will determine how quickly the electrons move. Okay, and remember then, if the electrons are moving more quickly, then your man counting them is going to have to count much faster, so you've got an increase in current. Okay, if the difference between the negative and the positive is quite small, then they'll move at a nice leisurely pace, and counting will be 1, 2, so the current will be quite low. Okay, so yeah, chemical reaction happens in here inside the battery. That creates an overall negative charge on one terminal and an overall positive charge on the other terminal. Depending on how strong this chemical reaction is and how negative this negative charge is. So like it might just be like a -2 or something, or it could be a -20. So whatever the difference is between these two, that will give you the driving force, and that will determine whether it's a very slow moving current or a very fast moving current. Okay, so the difference between these two is referred to as the potential difference, and then literally just another word for it is voltage. Okay, how do you measure voltage? The unit, first of all, the unit for voltage is the volt, okay, capital V, and voltage is measured using a voltmeter, okay, so they're all very important. So essentially when you're measuring voltage, it's not the same as having to count it. The way voltage works is that you pick a point on the circuit, so let's say this point, and then you pick another point on the circuit, this point, and you want to know what is the difference between them. So you put one bit of your voltmeter there, you put one bit of your voltmeter there, and your voltmeter will give you a reading for what the difference is. Okay, so a voltmeter is used slightly differently. So if I use this one, I have a voltmeter over here. So if I want to figure out how much voltage has been lost across the battery or across the bulb, I put one bit there and one bit there. Okay, and that's telling me that there's 54 volts being lost across that bulb. Okay, that is the potential difference between the left-hand side of the bulb and the right-hand side of the bulb. Okay, so it's kind of like, here's this person here, right? So this is an idea of how potential difference works. So here's your battery down here, and this person is leaving the battery with loads of potential. Okay, potential is ability to do stuff. Okay, so this person here has loads of potential. Okay, his little bucket is full. Okay, and the potential is the ability to complete a task. Okay, so off he goes. As you travel through the wires, there's not a whole lot, it doesn't require an awful lot of energy to get through the wires. Okay, so you can see the way his little his bucket is a little bit emptier up here. Okay, so he's used up some getting from this point around here to this point. Okay, but now he needs to light the lamp. So you can see he uses almost all of his potential lighting the lamp. And then he continues on, and then it's even emptier by the time he gets back, and then he jumps back into the battery, fills it back up, and out he goes again. Okay, so that's how potential difference works. Okay, it's an ability to do something. So when you have a component in your circuit, like a lamp, like a bulb, you're going to lose almost all of your potential in that bulb. Okay, which is why that's where the biggest loss was, you can see. Okay, so whatever current leaves the battery, the same current returns. So once you have a battery and the battery produces the difference, and that drives the speed of those electrons going around, that doesn't change. Okay, so whatever driving force the battery has, that's the speed the electrons move at, and that's the end of it. Okay, the voltage or the potential difference is different. As he moves around, this person is losing potential energy all the time as he goes around the circuit. Okay, he loses a little bit in the wires, he loses a lot in the bulb. Okay, let me just, was there something else I wanted to show you there? No, I don't think so. Okay, so what is the difference between current and voltage? So current is a measure of the number of electrons flowing along the wire. So like I said, whatever the driving force in the battery is, that's the speed that the current will move around. The voltage is the ability of those electrons to do a particular task, like light a bulb or something like that. Okay? Right, so for your homework, I want you to use this PhET simulation, which is this yoke here that I've been using. And I want you to build a circuit with a voltage of 12 volts. So if you look here, if I click on the battery, you saw me do this earlier, I can play with the voltage. Okay, so I want 12 volts for the battery. I want you to include 2 bulbs, so I only put 1 in, you'll need to put 2 in. And I want you to measure the current and the voltage. So you measure the current using your ammeter, and you measure the voltage using your voltmeter, and I've showed you how to do that. Okay, you're going to measure the voltage across each of the 2 bulbs, so bulb 1, bulb 2. Now you're going to change the voltage to 24 and do the same thing, measure the current and the voltage, and then you're going to, what happened there now? I think, sorry, it's supposed to be 6, 12, 24. Okay, I want you to record all your results and see, can you answer this question? How is the current related to the voltage? Okay, so there's quite a few bits there, quite a bit of notes. Please make sure you can understand what current is and what voltage or potential difference, you can use either word, what that is. Okay, and then have a look at the PhET simulation and see, can you perform this little task? And the very important thing is, what is the relationship between current and voltage? Okay, I will chat to you on Monday.